Unexpectedly, galactic events of extraordinary scale happen billions of kilometers from Earth, reverberating throughout the universe. As of now, an equivalent event is approaching, causing shock even among scientists. A red monster star, positioned at the outer ranges of our galaxy, is emitting ominous signs across the universe. These signals have been captured by the James Webb Space Telescope. Cosmologists have uncovered deeply unsettling revelations about this legendary celestial body. Renowned astrophysicist Brian Cox offers a grave warning. A pressing question arises. Are we on the brink of witnessing a catastrophic cosmic explosion that could forever alter the natural night sky? Before delving into further details, make sure to subscribe to our channel if you haven't already. Now, the burning question remains. Will this impact Earth? And will it be visible from our planet? Stay tuned as we explore the answers to these compelling questions in this discussion. In the vast expanse of the universe, where the cycle of stellar birth, life, and death unfolds in mesmerizing wonder, one particular star has recently captured the attention and concern of both astronomers and the general public. This star, known as Betelgeuse, stands out prominently as a red supergiant in the constellation Orion, boasting immense size and age. While its striking reddish hue and fluctuating brightness have long fascinated observers, recent events have further heightened interest in this magnificent behemoth. As we delve into the essence of Betelgeuse, we find ourselves standing at the very edge of a potentially spectacular event in the star's life cycle. But what do these changes in Betelgeuse's behavior signify? Could we be witnessing the precursor to a monumental display of unimaginable magnitude? Betelgeuse, with a size approximately 1,000 times greater than our Sun, remains a colossal giant among stars. Its sheer scale stretches the boundaries of human imagination. Picture a star so massive that, if it were to replace our Sun, its surface would extend beyond Mars' orbit, enveloping Mercury, Venus, Earth, and Mars within its radiant grasp. This dramatic size underscores not only Betelgeuse's true magnitude, but also hints at its place in the cosmic life cycle. As a red supergiant, Betelgeuse is in the twilight phase of its existence, marked by expansion and cooling after a lifetime of fusing hydrogen into helium at its core. Questions arise about Betelgeuse's age. Despite being relatively young in human terms, estimated at around 8.5 to 8.8 million years old, it is considered ancient within the context of stellar lifespans. Its current status as a red supergiant reflects the culmination of millions of years of stellar evolution, characterized by profound transformations from a hot blue star to the immense red giant we observe today. The journey of stars like Betelgeuse unfolds as a narrative of continuous change, driven by the relentless forces of nuclear fusion and gravity. One notable aspect of Betelgeuse's current phase is its distinctive red tint. This deep red color arises from its relatively cooler surface temperature compared to stars like our Sun. While our Sun shines at around 5,500 Kelvin, Betelgeuse's surface is cooler, at approximately 3,500 Kelvin. This cooler temperature allows Betelgeuse to emit light in shades of red. However, this color is not merely an aesthetic characteristic. It provides insights into the star's physical state and the ongoing processes within its massive gaseous envelope. Adding to the intrigue surrounding Betelgeuse is its extraordinary color history. Ancient records from Roman and Chinese sources suggest that nearly 2,000 years ago, Betelgeuse appeared yellow. It wasn't until the 9th century that Arabic astronomers described it as red. This historical shift in color is not only a reference point in astronomical records, but also serves as an indicator of the star's transformative journey. The fluctuating brightness of Betelgeuse adds another layer of fascination. As a semi-regular variable star, its luminosity undergoes periodic variations. This dance of brightness has captivated astronomers and stargazers for centuries. Typically, Betelgeuse follows a 400-day cycle alongside a longer 5-year cycle, noted as early as 1836 by Sir John Herschel and perhaps even earlier in indigenous oral traditions. However, what truly sets Betelgeuse apart is its unpredictability. Unlike many stars that follow consistent patterns, Betelgeuse sometimes deviates from its usual dimming and brightening rhythm. This irregularity points to complex and less understood processes occurring within its massive structure. Recent astronomical discoveries have captured the world's attention. In late 2019, Betelgeuse experienced a startling and dramatic event now widely known as the Great Dimming. At that time, Betelgeuse, the red supergiant shining brightly in the night sky and a prominent feature of the Orion constellation, began to undergo a mysterious dimming. The dimming was so pronounced that it lost brightness at an average rate of 0.01 magnitudes per day, reaching its lowest luminosity by February 2020. Betelgeuse, usually visible to the naked eye even amid light pollution, significantly faded, a phenomenon noticeable even to amateur observers. However, there is a critical challenge in monitoring Betelgeuse's activities: the time dilemma. When we observe a star like Betelgeuse, we are not seeing its current state but rather its past, due to the time it takes for light to travel to us. Betelgeuse, situated approximately 725 light-years away, means that the light we see today left the star nearly 7 centuries ago. This time delay complicates efforts to predict and track sudden changes in a star's behavior, as we are essentially observing events that occurred in the distant past. The dimming of Betelgeuse serves as a stark reminder of the inherent complexities in astronomical observations and the limitations of our understanding when grappling with the immense scales of the universe and the mysteries of time. The captivating journey of Betelgeuse's cosmic performance was meticulously monitored by Andrea Dupree, the Associate Director of the Center for Astrophysics at Harvard and Smithsonian, along with her team. Utilizing the Hubble Space Telescope, they embarked on a 3-year study to observe changes in Betelgeuse's outer environment. These observations provided an unparalleled understanding of how a variable star like Betelgeuse behaves, with its regular expansions and contractions leading to fluctuations in brightness. The remarkable sensitivity of Hubble to ultraviolet light enabled the researchers to probe the layers above Betelgeuse's surface, which were partially heated by the star's activity. This study revealed valuable insights into the enigmatic processes occurring within this awe-inspiring red supergiant. Star's fierce convection cells, moreover, a definite examination of the Hubble spectra, gathered at different stretches throughout 2019 and 2020, facilitated the estimation of material movement within Betelgeuse's outer atmosphere. Specifically, the study focused on the magnesium-2 lines in the spectra, which offer insights into the star's atmospheric conditions. These observations revealed material traveling at velocities of around 200,000 miles per hour from Betelgeuse's surface into its outer atmosphere. This heated and dense material eventually extended millions of miles from Betelgeuse, forming the precursor to the dust cloud responsible for the star's dimming. Dupree and her team estimated that during the 3-month event, roughly twice the standard amount of material from Betelgeuse's southern hemisphere was shed. This significant mass loss is particularly notable because, like all stars, Betelgeuse continuously sheds mass, but at a much higher rate than our Sun. The scale of this mass ejection and the resulting dimming sparked discussions among astronomers about whether this event could signal an impending supernova explosion. The proximity of Betelgeuse, located around 725 light-years from Earth, adds to the intrigue. If such an explosion were to occur, it would be visible from Earth, presenting a fascinating opportunity to closely observe a supernova. Yet, the question persists: what does this dimming event mean for Betelgeuse's future? Does it signal an impending supernova, or is it merely a transient phase in the star's vast and complex journey? Various theories have been proposed to shed light on this phenomenon. One hypothesis suggests it could be a stage in the supernova process, gaining traction due to the widespread belief that Betelgeuse is nearing the end of its life cycle. Another widely accepted theory implicates dust, possibly originating from the star itself, obstructing our view of Betelgeuse. A third explanation examines changes in the star's photosphere, its visible surface layer, which could affect its apparent brightness. Comprehensive analysis, utilizing various observational techniques, contributed to unraveling this mystery. Spectroscopic evaluations showed a decrease in Betelgeuse's effective temperature, indicating the likelihood of a significant dark spot on the star's surface. This hypothesis found support in observations revealing a temperature drop of at least 170 Kelvin during the dimming period, highlighting significant surface changes. Ultimately, the key to understanding this extraordinary phenomenon came from humanity's careful gaze into space. The Hubble Space Telescope. Hubble's precise observations revealed that Betelgeuse's dimming was likely caused by a massive ejection of heated material into space. This material coalesced to form a dust cloud, blocking part of the star's surface and reducing the amount of light reaching us from Betelgeuse. The formation of the dust cloud was attributed to superheated plasma, which erupted from a large convection cell on the star's surface and traveled through its scorching atmosphere to the cooler outer layers. After cooling, this plasma formed dust particles, resulting in a cloud that obstructed light from about a quarter of the star's surface. Hubble's ultraviolet light spectroscopic observations, which began in January 2019, played a crucial role in reconstructing the timeline leading up to Betelgeuse's dimming. These observations detected signs of dense, heated material traveling through the star's atmosphere in the months preceding the dimming event. By December 2019, other ground-based telescopes also observed the star's decreasing brightness, particularly in its southern hemisphere. Initially, this material appeared brighter than the star's usual radiance, eventually culminating in the formation of a shadow as it dispersed outward and cooled. The concept was straightforward. This outward flow of material and the resulting shadow were responsible for the star's sudden dimming. The scale of this ejection is truly remarkable, thrusting Betelgeuse into the cosmic spotlight. The star ejected an estimated 400 billion times the mass typically released in a standard coronal mass ejection. This expelled material was thought to be enough to outweigh our Moon several times over, marking a significant event for Betelgeuse and advancing our understanding of stellar mechanics. But what are the implications of such a massive release of material for Betelgeuse and broader theories of supernovae? Conventional thinking suggests that red supergiants like Betelgeuse typically shed mass before reaching the catastrophic peak of their existence. However, the magnitude of this release challenges this idea, hinting at a potentially more volatile and unpredictable final stage for these stars. Could Betelgeuse be preparing for its grand finale, a supernova explosion within the next few centuries? Later research speculated on the timing of such an event, suggesting it might occur sooner than previously expected, perhaps in just a few years. Furthermore, the concept of the bow shock adds another vital layer to the Betelgeuse puzzle. As this massive star races through space at around 67,000 miles per hour relative to its surrounding interstellar medium, it creates a bow shock, akin to the wake formed by a moving boat's bow. This phenomenon arises from the star's outer layers interacting with interstellar gases and dust, offering a spectacular display of the star's dynamic behavior and its interaction with the cosmic milieu. But what about Betelgeuse's recent behavior? Its surface cooling and reduced density observed following the ejection event leave the star in a disturbed state, even years later. Hydrodynamic simulations suggest a connection between the star's convective activities, the mass ejection, and the subsequent changes in its oscillation modes. This ongoing instability raises questions about the internal processes driving these changes and their potential implications for the star's future. Moreover, the observed mass loss rate of Betelgeuse exceeds that of many other stars, reflecting a complex interplay of internal forces. Nevertheless, with energy continuously dissipating through shock heating and mass ejection, Betelgeuse's rhythm is shifting. The very nature of these mass losses points to the star's dynamic and somewhat erratic life cycle, prompting astronomers to rethink their models of stellar evolution. The implications of Betelgeuse's unique behavior stretch beyond its own life cycle, offering invaluable insights into the evolutionary processes of massive stars. The recent dimming event serves as a reminder of the dynamic and often unpredictable nature of red supergiants, challenging existing models of stellar evolution and supernova prediction. While Betelgeuse's behavior may hint at an eventual supernova, the timeline remains uncertain. Whether this dramatic outburst signifies the star's imminent collapse or a more prolonged phase of instability, one thing is clear: Betelgeuse has captured the attention of astronomers and the public alike. The potential of witnessing a supernova within our lifetime is a rare and thrilling possibility. Such an event would not only illuminate the night sky but also provide an unparalleled opportunity for scientific observation and discovery. Modern telescopes and observational technologies, combined with advancements in computational modeling, position humanity to glean unprecedented insights into the mechanics of supernovae and their aftermath. Betelgeuse's recent mass ejection and subsequent dimming underscore the importance of long-term monitoring of variable stars. Observatories worldwide are now focused on tracking the star's behavior, seeking clues about its future and the broader mechanisms governing the life cycles of red supergiants. The study of Betelgeuse also highlights the interconnectedness of stellar activity, mass ejection, and the formation of interstellar dust, key components in the ongoing cycle of star formation and destruction that shapes our universe. As Betelgeuse continues its journey, it reminds us of the vastness and complexity of the cosmos. Each observation, every anomaly, and all the unanswered questions contribute to our ever-growing understanding of the stars that light up our night sky. Whether Betelgeuse is nearing the end of its life or simply entering a new phase of evolution, it remains a stellar beacon of discovery, urging us to look up and wonder,